So we have been doing some investigations of circles and how we come up with the equation for circles and polygons and different parts of circles. Can anyone start us off as we move into now semicircles? Just remind me of what is the form of the equation
R
for a
squared
circle.
equals x squared minus y squared, or no plus?
Yeah, I want to do it this way just for the moment.
Okay.
Okay? But that was that's where we started with the basic form, and one like this, where the centre of the circle is the origin, yes, we can express it like that. Okay, remember we had the extra one with r minus 8, so x minus h all squared, and y minus k all squared. But for a basic form, where the centre of the circle is the origin, that is entirely sufficient for the equation of a circle. Remember I did say that it's not a function, because we can draw a vertical line through any number of places of that circle, and we will get two places that are crosses. There are two sets of points that have the same x value. So if we want to turn this into a function, we need to be able to create another form of a circle that doesn't have that. What's the easy way to do that? Well, how do we change this so that maybe there's only one place that it cuts?
Hang on, I've got this.
But how do we remove a part more of a point?
Cut
Sorry?
it off.
Yeah, cut in half. And in fact, we just say, let's just consider a top half or a bottom half. For the moment, let's consider a top half. Okay, so now we're looking at a semicircle, and like I say, usually when we do our semicircles, we have like a straight line here, but we're just going to consider the actual part of the circle itself, which is the line. So it's just half of that line, that circular line. That's now a function. Why? Because anywhere you go through it now, there will only be one place that the vertical line touches. There'll only be one pair of values that has a particular x value. Okay, not two pair of values. Okay, so how do we reckon we can arrange our equation to reflect now the fact that it's half a circle?
Divided by 2.
That actually makes a bit of sense, but it's unfortunately not the way we can do it. Because we need to be able to say, all right, what have we done? By taking those things, this part of the line of things, what have we taken away from the set of points? Remember, we started yesterday by saying the circle is the set of all the points that are equidistant from another fixed point. Okay, and so all of these points along this semicircle here, but also all of these points along this part of the circle, they were all equidistant from this centre, in this case, from the origin. But what have we done? We've taken away, I guess, half of the points. Can you see what I'm saying there?
Yeah.
But what is common about all of those points?
They're positive. Negative.
So I actually meant the ones we've taken away, but you're saying the ones that are still there, they're all positive. Absolutely. So all we've got left now are positive what?
Y values.
Positive y values, that's right. So because over here we've got some positive x and these ones over here, and they're negative x, but all of them are positive y. So what we're saying now, we're actually getting rid of any y values that are negative. Okay? And so we could say, all right, let's do a little bit of rearranging of this. We can go y squared equals r squared minus x squared. Now that is still the equation of a circle. It's not the way that we normally write it, but that still actually is a very true statement for the equation of a circle. You happy with that? I'm just moving the x to the other side. Okay, but now say, all right, I want to now just focus on the positive things. At the moment, it could be positive or negative y values. Could go into this and be squared, and they kind of all turn out to be the same thing. That's why we end up with two y values for the same x value, because it will be positive or negative. But if I take a square root of both sides, usually what happens when we want to take that square root, we've got to say, well, it could be positive or negative. But what are we going to say?
Positive.
We want just the positive. So we're going to say, all right, this becomes y equals, and let's say normally we would write plus or minus the square root of r squared minus x squared. But we only want the values for y that are positive. And so we're going to say that y is the positive square root of r squared minus x squared. And because it's the positive, we don't need to write the positive in front. If we decided we wanted the bottom half of this circle instead, we would say that is y equals the negative square root of r squared minus x. So depending on whether we want the top half, that's the positive y values, or the bottom half, that's the negative y values, we will either have the positive square root of r squared minus x squared, or the negative square root of r squared minus x squared.